Hello everyone, my name is Luigi P. Beltran, and today's video, I will explain my answer in assignment 3 in Discrete Math of 4IT. Number 1. Let Q of x be the statement x plus y greater, greater than 2x. If the domain consists of all integers, what are the truth values? A. Q Q of 0 equals x plus y greater than 2x. So, we will distribute the 0 to x and the y becomes 1. So, 0 plus 1 greater than 2 times 0. 0 plus 1 is 1 and 2 times 0 is 0. So, 1 is greater than 0 is true. B. Q Q of Q1 Q negative 1 equals x plus y greater than 2x. So we distribute the negative 1 to x and y become 1. Negative 1 plus 1 is 0 and 2 times negative 1 is negative 2. So 0 is greater than negative 2 is true. C. Q1 x plus y greater than 2x. So we distribute the 1 to x and y to 1. So 1 plus 1 is 2. 2 times 1 is 2. 2 is greater than 2 is false. D. Extension qualifiers Q of x equals x plus y greater than 2x. So we make the sample table to solve this. For x is negative 3, negative 2, negative 1, 0, 1, 2, and 3. So if we distribute negative 3 to x, will become false, and for negative 2 false, negative 1 true, 0 is true, 1 is false, 2 is false, 3 is false. So we have 2 true, so letter D is true. E. Universal qualifiers Q of x equals x plus y greater than 2x. So we make again a sample table. Negative 3 is false, negative 2 is false, negative 1 is true, 0 is true, 1 is false, 2 is false, 3 is false. So we have 5 false, so A is false. F. Existent x not Q of x equals x plus y greater than 2x. So we find the negation of this sample table. So negative 3 is true, negative 2 is true, negative 1 is false, negative 0 is false, 1 is true, 2 is true, 3 is true. So we have 5 true, so F is true. And for letter G, universal qualifiers x not q of x equals x plus y greater than 2x. And we copy the sample table in here, and we have 2 false, so letter G is false. Number 2, determine the truth value of each of these statements if the domain consists of all integers. A. Universal qualifiers in open parenthesis n plus 1 greater than n. My answer is true, because if we take in integer in n and add 1 in it, it will be always greater than the second n. Example, if we let n equals 1, 1 plus 1 is greater than 1. 1 plus 1 is 2 greater than 1. So it's true. B. Existent n open close parenthesis 2n equals 3n. My answer is true, because if we let n into 0, so 2 times 0 equals 3 times 0. So this will become a 0 and this will become a 0. So this is true. So my answer is true. C. Existent n open close parenthesis n equals negative n. My answer is true. Example, if we let n into 0, so 0 equals to 0 is true. So this is true. D. Universal n open close parenthesis 3n less than or equal to 4n. My answer is false, because if we let n equals to negative integers, example, negative 1, 3 times negative 1 equals negative 3, and 4 times negative 1 is negative 4. So negative 3 is not less than and equal to negative 4 is false. Number 3. Express this statement using predicates and qualifiers. The statement is, there is a student who has taken more than 21 credit hours in a semester and received all A's. So will it Px be X is for has taken more than 21 credits hours in a semester, and Qx be the X for receive all A's. So we use existent, because in the statement they said there is a student who has taken more than 21 credit hours in a semester. So we use statistical qualifiers and open close parenthesis p of x, and we use the conjunction because in the statement he used and q of x close parenthesis. So that's all my answer.